everyday industrial reactions. For this episode, metal mining by Mathew, Safi, and Savio. Introducing you guys to metal mining, we will start off with two simple questions. For our first question, why do we mine metals? The reason why the mining industry exists is because it's a source of minerals and gems. It is a source of jobs. Society is literally built upon what we mine because, it contributes to the global economy and whatnot. Without minerals, we wouldn't have modern infrastructure, vehicles, electronics, machinery, and the slides I'm presenting on right now, Google Slides. For our second question, where does most metal mining take place? Did you know that China has the largest mining industry in the world? This country has extracted over 4.1 billion metric tons of minerals, fossil fuels, iron, and other metals, according to the 2018 stats from the World Mining Congresses.
The history of the metal mining industry. In this section, we'll be talking about the purpose of reactions within the industry, an example of a chemical equation that can take place, how the product is made, and the industrial process of how gold is leached. What is the reaction used for? Many chemical reactions occur in mining, but today we will be talking about gold leaching. In both technological and economic terms, cyanidation is the only option for recovering gold from low-grade and finely dispersed gold ores today. The selectivity of free cyanide for gold dissolution and extraordinarily high stability of the cyanide complex are two of the key advantages of cyanidation. The most significant disadvantages of the procedure of cyanidation are the toxicity and disposal issues associated with it, leaching pollutions, and the environment if proper safeguards are not taken. The next slide, sample molecular equation and its states. The sample equation for the gold leaching process using sodium cyanide is 4Au solid plus 8NaCN aqueous plus O2 gaseous plus 2H2O liquid, which yields 4NaAuCN2 aqueous plus 4NaOH aqueous. The type of reaction that occurs in this is an oxidation reduction, also known as a redox reaction. It's a type of chemical reaction in which two chemicals exchange electrons. Any chemical process in which the oxidation number of a molecule, atom, or ion changes by gaining or losing an electron is known as an oxidation reduction reaction. NaCN is an oxidizing agent in this reaction, Au is a reducing agent, and O2 is an oxidizing agent. Reaction conditions. Ideal temperatures and catalysts. In industrial manufacturing operations, the ideal temperature for cyanide leaching gold is anywhere from 25 to 30 degrees Celsius. Any less than that range and the cyanide can't dissolve the gold. Also, in practice, using hot solutions to extract gold from an ore has a number of drawbacks, which includes the cost of heating the ore and the solution, increased cyanide decomposition due to the heat, and increased cyanide consumption due to accelerated reaction between cyanides in the ore, such as copper, sulfides, iron, and cyanide. Speaking of copper is also a common catalyst for boosting the rate of gold leaching. However, it's usually disliked in the industrial manufacturing companies since it results in a high consumption and a complicated gold recovery procedure. This slide will cover more on the industrial process. A video of a length of 4 minutes will explain the industrial process of how gold is leached from the ground using the cyanidation process. A continuation of the industrial process. Industrial processes continued from the last slide. When compared to cyanidation leaching, fat leaching provides far more control over the leaching process, thus making it more favored in industrial processes. This results in quicker, more efficient, and targeted leaching. Managing temperature, acidity, aka the pH level, and solution flow rates using a vat leach, which gives a considerable number of benefits over cyanide leaching. This control provides a more selective leach, allowing recovery of lithium and boron while reducing the number of other elements leached into the solution. Other than lithium and boron, gold would be the main thing that would come out of this leach, since gold is very expensive and will be expensive for years to come.
Molecular properties and structure. In the upcoming slides, we will go through each point mentioned and elaborate more about our reactants and product. In the reactant section, there are some pure elements that are found in our reactions. First and foremost, gold, a pure element that is non-reactive, allowing it to not rust, and it's oftentimes used as jewelry. Oxygen, which we never saw but breathe in and can't live without, is also another pure element in the reactants. Oxygen also comes from ocean and plants. Moving on to our last element, which is water, usually or most of the time slightly blue. Water is something we drink and is used for several things in our daily lives. Water also surrounds 97% of our earth, but remember, only 3% of it is drinkable. Moving on to our reactant compounds properties, which is sodium cyanide. It appears that it is ionic compound because sodium is cation and cyanide is anion. This compound is slightly porous and usually appears solid or powdery state. As shown, it is very toxic. In fact, 1.5 milligram is enough to kill a human being. So please, if you have any kids around, keep them away from it. More about sodium cyanide. It's always white substance regardless of the state. It's super reactive substance, especially with acids, water and moisture. The substance also reacts with any type of heat easily, forming a really toxic hydrogen cyanide gas that can also lead to death. Keeping sodium cyanide stored in cool areas and away from direct sunlight is the first step you should consider when dealing with it. As shown in the right upside, it's our beautiful compound structure too. Moving on to how is sodium cyanide used. Since this substance is extremely dangerous, it's usually used for fumigation, electroplating, and extracting gold and silver from ores, which is the reason why the compound appears in our reactants. Sodium cyanide helps dissolve the gold from the ore by applying it on crushed ores that enter the process of gold extraction. From there, the gold is separated from the ore and it enters different processes that are required in order to clean it. This is the main process of sodium cyanide in gold extraction. As mentioned, for other uses, could be fumigation, which they use sodium cyanide to kill the pests. This process is quite dangerous and the areas are usually covered when getting it done. For electroplating, sodium cyanide helps controlling the concentration of metal ions. Sometimes it also blocks the electrons transport, and that's why it is used in solutions. Moving on to our products, and specifically sodium gold cyanide product. Since sodium gold cyanide is a compound that appears in product, yet it does not have any properties. In fact, it is a bunch of elements that are combined forming a compound that just have weight. In this case, this compound can be broken down into gold cyanide. Again, since gold cyanide is also or basically gold attached to some cyanide without any special properties, it will also extract into pure gold and cyanide, which is what later on happened. With that being said, it means that we are left with CN or cyanide alone to work with, as shown in the structures below. To cyanide properties we go. As shown, cyanide is a polar molecule, which because of the unequal distribution of charge between the carbon and nitrogen, because of their large electronegativity differences. This is also colorless gas. Unless it's bonded with other elements like sodium or potassium, it won't form any solid state. As most of the gases, this one also does not have smell, but some people usually describe it as a bitter almond. Now you might be asking, since cyanide is gas, how is it used or what are their properties? Since cyanide is gas and usually gases are unique when applied, in manufacturing, cyanide is used basically by just being present in the chemicals and solutions. This helps producing plastics, paper, and textiles, which are stuff that we at least use one of them every single day. Moving on to our last product, NaOH, or known as sodium hydroxide. Here are some properties of this product. It is a corrosive substance, comes in solid and liquid form, but each one of them have different appearance, does not have smell, and it's one of the strongest intermolecular forces due to it having hydrogen bonding and an interaction between an ion and dipole. Now for sodium hydroxide reaction to happen, it's just the form of sodium cyanide plus water reaction that forms this compound. Other than that, there are no specific properties for it in gold extraction. However, this does not mean sodium hydroxide is not used in our lives. Soap and detergents all contain sodium hydroxide, which helps manufacture ionic surfactant. In drain cleaners, sodium hydroxide is able to convert fats and greases into soap by soapification. The soap is then easily removed by water. Its ability to effectively dissolve fat and grease deposits makes sodium hydroxide an excellent stainless steel and glass cleaner. In product that explodes, sodium hydroxide loves reacting with metals such as zinc or aluminum. This causes a formation of a really flammable and explosive gases of hydrogen. About dyes, it's basically used to remove the fats and contamination before any dyeing processes.
Metabolism and reactions. In this section, we will be talking about the optimal conditions for the compound to react, such as temperature and concentration. We will also be talking about percentage yield, limiting reagents, and why these compounds are chosen as the limiting reagents by the industry, and our favorite part, calculations. How to make the most out of your materials. These are the conditions that you'll need for maximum extraction efficiency. So, you would need a pH solution of 10.11, a solids percentage of 36.07, a sodium cyanide concentration of 729.56 parts per million, a particle size of 37.52 micrometers, and working conditions between 15.5 and 21 degrees Celsius. If you're American, it's 60 to 70 degrees Fahrenheit. This is to allow the gold to be the most soluble while balancing the consumption of sodium cyanide. The more cooler it is, gold is less soluble. The more warmer it is, cyanide consumption will decrease efficiency. These specific conditions are required for the most optimal yield, since more or less of the listed measurements will only negatively impact the yield. It's like how not following the recipe to a cake will oftentimes result in a lower quality cake. Or, if you mess it up enough, you get no cake at all. For example, if the solution didn't allow the gold ore to dissolve within it, then the gold cannot be extracted altogether, since it will stay as an ore. If chemical concentration was not at the desired level, the process will be less efficient. Oh, here we got some cool calculations for the chemical process of gold leaching. The question is, how can we synthesize 1 kilogram of our product? So, at the top of the slide, you will see the chemical reactions and our givens. Disclaimer: givens for moles were made up for the sake of the example. Our main focus here will be on gold and sodium cyanide as reactants, and gold-infused sodium cyanide as our product. On your left on the slides, you will find our limiting reagent calculations. As you can see, gold is our limiting reagent, which makes sense, as we will elaborate on the next slide. Finally, on the right, you will find our calculations for the mass of gold needed to make our product, which is listed in the slides. As a result, through careful calculations, we have discovered that it takes 7.243 times 10 to the power of 2 grams of gold to make 1 kilogram of our product. Gold as a limiting reagent. So now, we will discuss why gold is selected as the limiting reagent for this specific reaction. Mining in general is hard, expensive, and dangerous to the people who work there. Digging pits or tunnels deep into the Earth's crust is expensive, along with acquiring, maintaining, and using the equipment. Oxygen must be supplemented to the workers working in deep mining tunnels, which in itself poses a danger to the workers. If, for example, a collapse occurs and oxygen is cut off. Gold, like most minerals, is non-renewable. since it took millions of years for it to form, like, coal, making it the most scarce element in the chemical equation, hence why it is the limiting reagent.
The ethics of the metal mining industry. In this section, we will be talking about the effects this industry has on people and the environment around it, effects of chemicals that can harm the environment, and concerns with how metal mining takes place in other countries. People living near mines are affected by lead, zinc, copper, and mercury, which leads to lower lifespans. In Bolivia, the average miner lives between 35 to 40 years old. Mining mercury produces a variety of health issues, including neurological illnesses and kidney damage. Respiratory issues including asbestos, silicosis are caused by small particles from enormous volumes of dust created by mining, like blasting and drilling. Even if someone lived with a miner, they could also experience the adverse effects of poisoning, leading to the illnesses mentioned. Likewise, child labor is prevalent in Colombia's artisanal, non-formal coal and gold mining industries. The young people crush rocks, dig in the ground with tools or their bare hands, drain mines, and hoist large objects. They labor long hours and are exposed to hazardous instruments, hazardous substances, poison fumes, explosives, and compounds like mercury, as well as bodily injuries and mutilations. According to the mining census conducted in 2010 to 2011, Colombia has 14,357 mining sites, 63% of which are mined without a title, and 72% of which do not comply with mining rules such as occupational safety and health (OHS) requirements. Miners, especially female miners, are frequently paid in cash as day workers and do not have contracts. The reason these children experience such harsh conditions is because of the economy and how many third world countries need the metal mining industry to survive, which will be covered in a later section. Effects of cyanide on the environment. Effects of cyanide on the environment. Cyanide is frequently dumped into streams during gold mining and when mine waste ponds burst and spill. According to mining firms, cyanide in water swiftly degrades. However, this is only true when there is plenty of sunlight and oxygen. Even so, it leaves behind additional dangerous compounds. If cyanide is spilled underground or the weather is gloomy or rainy, it can linger for a long time, killing fish, vegetation, along with the rivers, rendering the water unfit for drinking and swimming. Some governments have even outlawed cyanide because it is so toxic to the environment and human health. With all the negatives mentioned, we should also mention how to make mining more sustainable for the environment. In C2 leaching, also known as solution mining or C2 recovery, it involves dissolving the ore and pumping the pregnant solution to the surface, where the minerals may be collected. As a result, there is a minimum surface disturbance and no waste rock or tailings are produced. The ore body, on the other hand, must be permeable to the liquids employed and situated such they do not produce groundwater elsewhere. Furthermore, mining operations require a lot of non-renewable resources like minerals, but also consume a lot of other resources including electricity, water, and soil. Mining operations can maximize their efficiency and sustainability by taking a two-pronged approach of reducing inputs, such as diverting water and water pumping groundwater, or using alternative energy sources like solar power or wind power, and other outputs by using cleaner production techniques and reducing mine waste and byproducts. Seeing as all the consequences mining produces, why do we still need mining despite it? Because if it can't be grown, it has to be mined. Mineral goods are key components for cell phones, automobiles, energy towers, solar panels, wood turbines, fertilizers, machines, and other types of buildings. Likewise, mining is the economic backbone of many developing countries. According to the International Commission on Mining, at least 70 nations are very dependent on the mining sector, and most low-income countries rely on it to live, which means this is why the children and women live in harsh conditions in mines. According to the same report, mining contributes for as much as 60 to 90% of total foreign direct investment in several low-middle income nations. A continuation of the previous slide. Why do we still need mining? Well, mining is first and foremost a source of mineral commodities, which are necessary for all countries to sustain and improve their living standards. Mined resources are required for the construction of roads and hospitals, the manufacture of vehicles and homes, the manufacture of computers and satellites, the generation of energy, and the provision of a variety of for goods and services to come. Mining is also economically significant for producing for areas and countries. It generates jobs, dividends, and taxes to fund hospitals, schools, and other public services. Population, urbanization, and income growth will increase for demanding buildings, automobiles, and consumer goods, boosting the need for mined materials as these building blocks of expansion.
Also, don't forget, at the end of the slides, you're gonna find our citations.
We hope that these slides influence Dr. Tina Wojcic to hire us at Wojcic Corporations through our various research and recommendations to the metal mining industry. Thank you, Ms. V, for making this a great experience on our behalf, Savio, Mathew, and Safi. We send you prayers and good wishes for whatever field you choose to pursue, whether it be teaching, research, or even going for a doctorate.